In this video, we'll be discussing properties of logs and how to use those properties. So, the three properties of logs that if you have a log that has two functions multiplied together, then you can break them up into log of one function plus log of the other function. Same thing, if you have two functions that are divided, then you can take the log of one function and subtract the log of a second function. And if you have a log of a function that is raised to an exponent, you can actually take that exponent and you actually can throw it in front of the log. So those are the three properties of those logs. And again, we discussed the rules in a previous section to where these three or these four rules will always apply. So let's actually try to use these properties to solve this. So we have two logs that are subtracted. That is the same thing as one log with those two functions divided. 20 divided by 4 is 5. And interesting enough, we actually can take the log base 5 of 5. We know is the number 1. Why? Because 5 to the first power gives me 5. So I know that this answer is 1. Anytime you have a log of a number of its base, the same base, you can cancel them out and it will give you 1. In this case, we have two things going on. First, we have a number in front, which means we can throw it back into the exponent. So I can say that log base 9 of a third plus log base 9 of 3 to the third. We can do that. And now because of the addition, that means that we can make it 1 log and multiply. 1/3 times 3 to the third is 9, actually, because 3 to the third is 27, and a third times 27 is 9. And then we are actually back to log base 9 of 9. And since we have log of a base of a number of it's the same number, it's going to be 1. Same thing here. We have a number in front, which means it was originally an exponent. So we can say log base 4 of x squared. And then this plus of log base 4 of y, because of the plus sign, just like the subtraction means division, the plus sign means that I can actually make them 1 log of multiplying them together, and you are done. Now, you also can expand logarithms. So for example, we have two functions that are multiplied, which means I can separate them into x cubed plus log of y. And now, the only thing left I have to do is I'm going to take that exponent and I'm going to put it in the front of the log of x, because exponents you can put into the front, and you're done. Now in this case, if you think about please excuse me dear Aunt Sally, you're first going to have to actually throw the 3 in front before you break it up. So the first thing I'm going to do is go ahead and throw the 3 in front. Now that we have division, I know that I can subtract these two logs, but you got to be careful. The 3 has to stay in front, so I'm going to use a parentheses. And then now I can subtract my functions. You can distribute the 3 if you want to. It does not matter, or you can keep it in front. In this case, we have a couple things going on. We have multiplication, we have division, and we have some exponents. So I'm first going to go ahead and split it all apart. So I have log of s plus log of square root of x, and then that's going to be minus, because division, log of r squared. Now the only thing I have to do is I have to make my exponents go in front. There is no exponent with s, so it's just going to be s. This square root is the same thing as 1/2 as an exponent. So you're going to put a 1/2 in front, log of x. And then this 2 needs to be put in front of the r. And that would be your final answer. Be really careful. You don't put a square root in front. A square root as an exponent is 1/2. That's why there should be a 1/2 in the front. You can't use a square root. So let's recap. I want you to try each of these 4 to determine the answer, and then I will show you the answers. Again, this is a true or false. So for each one of these, you want to know if the left side equals the right side. So the answers for there are going to be either true or false. Okay, for the first one, because you have addition between 2 logs, that means you can multiply the 4 times 8 to get 32. We want to know, does log base 32 equal 5? So 2 to the 5th, does that equal 32? 2 to the 5th, does that equal 32? And yes, it does. And so your answer is true. In this one, when you have subtraction, it means division. So you would have log base 4 of 7 divided by 3. And we want to know, does that equal log base 4 of 4? Anytime you have the same logs, then these two should be equal. Is 7/3 equal to 4? No, it is not. So your answer is false. Again, you cannot subtract 7 minus 3 to get 4. Remember, the properties for logs is if it's subtraction, that means you divide those numbers. Same thing here. They want to know if log of x minus 2 equals log of x divided by log of 2. It does not. So the answer here is false. You actually cannot break up. Now, if I said log of x minus log of 2, then I would have said that that's the same thing as log of x divided by 2. This does not equal log of x divided by log of 2. These are not the same at all. You cannot say that. And you also cannot distribute. You can't say log of x minus log of 2. You cannot distribute a log. That does not work. And even if you did distribute it, you still wouldn't get that either. So the answer is automatically false. This x minus 2, if you think about them as being married, they are both with the same log. You cannot separate them apart. In this case, because you have addition, that means you can multiply the function. So you have x times x squared plus 2, which that you can distribute. So you have x cubed plus 2x, which does give you the other side. So your answer is true.